All right, welcome everybody to this lesson. We are continuing on with Pygame today. Last time we kind of created our basic structure where we imported the engine, we installed it, and then we turned it on with this init function. And then we defined the size of our screen. We chose 800 by 400 pixels last time. It's 800 wide, 400 tall. And then we had a particular command. So all the commands that are part of the Pygame engine started with pygame dot, and this one said like in the display settings, use the set mode function. So there was kind of a pattern with these. Everything starts with pygame, but then it was pygame dot display. We saw another one here. It was pygame dot event down here. So there's a whole section in the Pygame library of events. So we're going further and further into more specific layers as you add more and more periods as we go. And they usually end up with some sort of function or method that does some things. The first case was set mode, and that kind of set the screen mode. This get function under the events just returns us all the possible events that we could be getting, like mouse clicks and keyboard input. We had one if statement in here that detected if they press the X, the close button at the top right of the screen. At that point, we set running was equal to false, and this whole loop this is the game loop, so this one goes until running ends up being false. So when we click quit, we exit the loop, and then there's only this tiny little bit of code here that was at the bottom, and it says quit the engine. So the Python file shuts down, we quit the engine, and the whole thing closes. So today what we're looking at doing is adding in a few different pieces. The first thing is that we want to upload some images. If you have a game, you likely need some assets. Assets are like different files that are going to be used by the game. So if you think along the lines of something like Minecraft, like all the little sprites, the icons that you'd have in your inventory, those would all be stored as game assets. So we're going to have in this lesson a background asset, which is just a background image, and it's going to be a photo of Spongebob and Patrick. It's going to be our main character. So we'll put those in, and those will create Pygame surfaces, they're called. And we're also going to then write some code to make Spongebob and Patrick move around the screen as we press the arrow keys. So we'll upload those images, create some surfaces, add some code to detect when we're using the keyboard input. And then we're also going to use a Pygame because it has this built-in clock command, and that clock will help us kind of regulate how fast the game is running. Remember that computers can run very, very fast, so if we don't set a clock, the computer's just going to run at max speed, which means everything will move super fast, so we do need to slow that down and kind of regulate it. But those are the three things we're looking at doing in this video. Okay, so first thing before we begin, I am still in my file here called pygame.test, and I have grabbed already the two images that are on our Brightspace page. So you will need to go to the page where this video is located on our Brightspace and make sure you download the Sponge 150 PNG. This is the photo of Spongebob and Patrick, and then there's the Sponge BG for background 720 PNG. So the numbers indicate how many pixels wide they are. So this background is 720 pixels, and the width of the SpongeBob background is, or the SpongeBob image is 150. So make sure you have these downloaded, and they need to be stored in your regular Python files folder. Okay, so if you called it something else, just make sure it's in the same folder as this file, pygametest.py, or whatever you've named your file. Okay, but it is important that these are in the same file, because if you have them somewhere else, how the code we write won't quite work. We need to locate, the correct file and where it is, so it works easiest if you put it in the same folder. Okay, so let's get going. So first thing I'll do is just bring up the background photo one more time here, because you can see in the bottom section here, this resolution of this photo is 720 by 397. I did get both of these images from DeviantArt, and I'll link those in the description in the YouTube comments. So this is 720 by 397, and SpongeBob 150 is 150 by 99. Okay, so what we need to do when we get in here is that we want this background especially to fill up our whole screen. So my width and height that I chose last time are actually a little bit bigger than they need to be. So I'm going to change that now. We're going to change the screen width, screen W variable, to 720 wide to match the image and 379 pixels tall. So I might as well change my comment there as well, that we want at 720 by 379 just to match the dimensions of the image that we have here. Okay, and to get the background in, this is basically going to replace that screen fill that we had here. This was this teal color that was, the RGB value was 100, 200, 200. So 100 in red, 200 in green, 200 in blue. So I'll just run this as it was. So we had a screen that looked like this. It was just this kind of teal background, but we are going to replace this with the Spongebob background. Okay, so we're going to, I'm going to delete this screen.fill command, and we're going to go through the code for the first time of how to add in an image. Adding in an image for, as we do the Spongebob and Patrick one, will be the same lines of code. We're just changing the file name. Okay, and as we put in our images, we are putting these in at the top of the file, same place where we're like setting up the variables, because these assets, these images, work very much like variables. They're storing some information that we do want to call back later. Just as we had variables to have the screen size, set up the screen, we're now going to have maybe image files that create surfaces here. So the line of code we need is we do need to actually store this as a variable. So I'm going to call this background. So this variable background is going to be equal to, so it starts with Pygame dot, and this is in the image section. So instead of pygame.display or pygame.event, this is pygame.image. Then it is load, and inside the round brackets here, we have to put the file name. So this is why it's important that the images are in the same folder as our current Python code, because then we can just write the file name. We don't have to write any sort of directory. We don't have to write any sort of folders where we're navigating to. We can just right away go ahead and say sponge set bg, capital BG, 720.png. So that should all be within the quotation marks. I'm using single quotes here. You could also use the double quotes, so it could look like, you know, this on both sides. They will both work. I'll just stick to the single quotes, just because that's a single key press rather than needing like a shift. And then we put one other thing at the end. We put this extra command on called command convert alpha. This just does a little bit of optimization. If we had a lot of images, this convert alpha just converts the image to something that Pygame can work with a little bit more quickly. So if we had more images, we would see maybe less lag. Might not have been a issue in the first place just because our game is pretty simple, but for larger games, optimization is something to keep in mind. So we've got our background, and I might as well declare my Spongebob as well. So I'm going to call this one Spongebob, even though it's Spongebob and Patrick, but it's also going to be pygame.image.load, and this file name is called sponge150.png. And same thing, we're going to do .convert alpha at the end of that, again for optimizing. Okay, and what we can do is put in some starting coordinates. The background is going to fill the whole space, so we don't really need to worry about where it's starting. But let's put Spongebob somewhere not like the top left of the screen. That's probably where he would end up. So we're going to say, we're going to have a variable called spongex, and this is going to be a variable that says, like, we have a width of 720 pixels, and we're looking at putting this, maybe somewhere halfway through. So doing a little bit of quick math here, if we cut 720 in half, that's going to be 360. So this isn't going to perfectly center things, but I'm just going to put this as 360 for now, and we'll adjust this maybe a little bit later. And then we're going to say sponge y. Our height is about 380, And if we cut that in half, that is like 190. So we'll start there. It's not going to be completely centered, but it'll be pretty close, at least to start with. Okay, so we've got our variables for our image files, but these are not yet being used, right? Just like how when we declare our variables screen W and screen H, that information isn't being used there. It wasn't used until we used the set mode command that then used the 720 and the 379 as the width and height of the screen. So we have these image files ready to go, but they are not yet being drawn to the screen. We're going to do the drawing inside of the game loop. Okay, so how this game loop goes, or how it works, is that every frame, every time this runs, so this is going to run many times a second, it's actually redrawing every single one of the images that we put in every single time. So things that we draw at the beginning of this loop will get drawn first, and things that get drawn later will get drawn after. So you can end up with some sort of layers here. Okay, the command that draws it is called a blit in Pygame. It's called like a block image transfer. It's an abbreviation. So blit doesn't really make sense on its own, but it is the drawing command. Okay, so what we're going to do is we're going to draw our images. So it's a screen. Here we get here. So we're referencing the screen variable, the one that we created, which was the Pygame display, and it's screen.blit. So inside of the round brackets, we have to say which surface are we creating, or are we blitting. So when we load in those image files, the background and Spongebob, Pygame is converting them to what it calls a surface. So when we blit, we're now going to write that surface to the screen. So it is blitting. It's going to be... we'll do the background first. Or actually, let's do Spongebob first. I'll show you how the ordering can affect things. So we're going to blit Spongebob, and then it requires a coordinate. So I'm going to open up a set of round brackets here. So this is a coordinate, just like in mathematics where you'd have an x comma y. And we want to pass it in sponge x and sponge y. Those two variables that we defined as 360 and 190 go in the screen blit. Okay, so you can see that the brackets are color coded. So just take a quick note to see that the blit has overall the yellow brackets on the outside, and then this takes in two different inputs. One is the image or the surface that we're writing to the screen. The other is where do we put it? What's the x and y coordinate? So we're going to do one more screen blit, so screen.blit, and we want to use the background. So it's the background, I'm going to spell that right, the background image, and we want this to fill the whole screen, so it's just going to start at the top left, 0, 0. That's where the 0, 0 coordinate is, measured at the top left of the screen. That means that when we go a little bit different than mathematics, is that when we go down on the screen, starting from the top left and moving downward, that's going to make the y-coordinate positive. In math, that would be a negative coordinate, but in Pygame and a lot of computer-related things, going downward, starting from the top left, is a positive y-coordinate, and moving to the right, just like mathematics, is a positive x-coordinate. So we are going to blit those to the screen, and we're just going to try and run this and hope that everything worked. So I'm going to run this, and we can see here, so that overall teal image is now replaced with the image we had, the background under the sea, but we can't see Spongebob anywhere. And the reason for that is the order in which I did the blitz to the screen. I did the... clear this out here. I drew Spongebob first, which is a smaller image, and then I drew the background, which covers up the whole space. So that's how we can kind of make layers of different images, just with the order that we write them to the screen. So the background should be the most back layer, the one way at the base. So I just want to put this before Spongebob. So if I write it this way, then we should be able to see Spongebob There he is. So it's actually a pretty nice little starting spot, starting on the sand. It's not centered like you can see. This image has kind of a square around it because there was a transparency. And where I ended up putting this was the center of the top left is right in the center of the screen or so. And since this image has a width and a height, that's why it looks off center. But we're currently measuring this coordinate in the top left of its box. And we can kind of see here if I click on Sponge 150, you can see that around Patrick and Spongebob, this would be the top left. This would be its kind of anchor coordinate. So that's the coordinate I'm putting in at 360 and 240, or sorry, 190. So let me just run that one more time. And we can see that here. So this kind of represents right here is around the center of the screen. I could adjust this to perfectly center SpongeBob and Patrick, but I'm not too worried about it right now, and it actually looks kind of nice the way it is. So we have these two images to the screen that already looks a lot better than the blank teal screen. Everything has character, everything is like drawn in the same style. It looks kind of nice. So we've got our two images on there, and they are now getting drawn to the screen, and every time this while loop runs, it is redrawing the background and SpongeBob. So that's important. It seems like a lot to do, that it's redrawing the background every single time, even though it's not moving. But this is how a lot of 2D games worked. It was just constantly drawing. This is different than if you have a 3D world in more modern games. Those are not quite done the same way, but for a 2D game, that's how it worked. Okay, so we've got kind of our first goal already done, is that where we had to upload the images and create those services. Now, first thing what I want to do is be able to move SpongeBob around, okay? So we're going to have to write some code to make that happen. So Pygame already has some different methods, functions available to us, just like how we can run through and look for any events, any new things like mouse clicks, keyboard input, etc. Just the same way we can do that, we can check on the thing getting pressed. Okay, so we're just going to do this in a new block, but we'll do it underneath. We'll keep checking for the quit first, but then we're going to check in for a key. So we're going to set a variable called key, and this is the Pygame method that just kind of returns if it got a key. So it'll be Pygame dot key dot get pressed. Okay, so even though right above here we just went through all the different events in this loop and checked if it was a quit, we could potentially move this code kind of in the same loop as the other one, but we'll just do it. We'll just separate it, even if it's a little bit less efficient. That's fine for what we're doing. We're just still kind of learning, so not having too many layers is probably a good thing. So this is going to return any keys pressed on the keyboard. Okay, so I think I mentioned we were going to use the arrow keys, but it's actually a little bit easier to code in kind of the gaming directions, which are WASD, just because it's a little bit easier to write which key that is. So we're going to write an if statement. So it's going to say if key, and then we have some square brackets here, Pygame K underscore A. So this here, we'll just say if this is true. So this key line on 38 is checking the key. And then if that key, and then also kind of this property here, if the property of the key is that it was the A. So this K underscore A there and the Pygame, that is kind of just needing to be there because we're using a library. But really all we're focusing on is this last thing here, what's after the underscore. If it's A, so if the key pressed is A, we want it to move a little bit. Okay? And that's all we want to do. So we're going to make a code block here. And what we want to do is adjust the x coordinates. So we're going to say sponge x is equal to sponge x minus 5. So we're reassigning the sponge x variable, and it's going to be moving to the left by 5 pixels. So it changes the variable for the x coordinate minus 5. So if A is moving left, D is moving right, W should move up, and S should move down. So we're going to have very similar conditions moving forward here. So we're going to say, now, else if. So there are 4 different possibilities. So we're going to say else if, and it's going to look almost identical. Key, then square bracket, Pygame dot K, and let's do the right side now. So we're going to say D. So it's almost the same line as before. Like I said, it's just the whatever's after the underscore is the main thing we're worried about here. The rest is just code that needs to be there because we're using the Pygame engine. So if it was D, we want sponge x to be equal to sponge x plus 5. Okay, and there is a shortcut way we can write this line here. I'll show you what it is in case you'd like to do it that way as you're following along. But we could say plus equals 5. That's a shortcut for saying sponge x is going to be sponge x plus 5. Here we could have done minus equals 5, and that is equivalent and a shortcut. But just for more readability, I'm going to do it the longer way here. Okay, so we're moving to the right. Now we have another else if. So elif key Pygame. You might even want to copy and paste some of this stuff and make the changes. Now we'll do the W. And if that is equal to true, so if we press W, then that should move up. So it's the sponge Y variable, and that's going to be equal to sponge Y. And we've got to be a little bit careful here because if we're moving up, we mentioned earlier that moving down was a positive coordinate, positive change in Y. So we actually want to subtract if W is meant to move it up. And then we'll say else if, again, key, and then Pygame. K, then this is S. If that is true, then we're going to say sponge Y, Y is equal to sponge Y minus, or no, sorry, this one's plus. We would be moving down in that case. Okay, so let's take a look at what happens here. Let's just try and run this and see what happens. We're going to run this, and I'm going to use my keys. Okay, so right now, this might be happening to you as well, is that Spongebob is running super fast. So I don't know where it is anymore. I've kind of lost it. And this is kind of that clock idea. I mentioned that your computer will run as fast as it can. And the whole idea of the clock is that it slows it down. Because this game would be unplayable right now at that speed. It's just too fast. It's running at the full power the computer can go. But I was able to move it, so that's good. So before I finish off with the if statements, let's go ahead and add that clock line in because it's only a couple of lines of code. So we're going to put that back up kind of in the variables. So we had our screen dimensions, then we had actually created the screen. We've got our image files. So maybe right here we'll do our clock variable. Okay, so clock is going to be equal to Pygame dot time. So now there's a time section. We're kind of learning a little bit about all the different things that are in the Pygame file. And then there is a clock function that will work. So clock is equal to Pygame.time.clock. So that's a variable, but again, it's not being used yet. So that's going to get used down in the end of our while loop. So most of the code that does anything is in the while loop. So we're going to put this right after the display update. This is where all of the blits and stuff that were queued kind of end up getting updated to the screen. So right after that, we're going to say clock dot tick, because clocks go tick tock, and we're going to say 60 here. Okay, so this delays the computer, and slows it to 60 frames per second. So by default, most monitors will run at a maximum of 60 frames per second, unless you had some fancier gaming monitor, and those can have a faster refresh rate. But for any of the lab computers at the school, 60 is as fast as we can go, and that's as much as we want to do. So we set the clock variable, and then we just set it to tick, so that would match 60 frames per second. So now when we run this, we can kind of use our arrow keys to move around, and we can see that it's going to go a much better pace. So there we go. So now we've got all of that stuff moving around. We got Spongebob. It can move around in the sea. You might have a little bit of some computers like flash a little bit, just because Pygame is, doing its best, but it doesn't always go completely smoothly. But as long as it's still responsive to your keys, that's totally fine. You can see mine is stuttering every once in a while, but that's not something to worry about. Okay, so I'm just going to add one little bit to this code here. So you can kind of see that I don't have an else here. I've got if, then else if, else if, else if. There's no else because that would respond to any other key. So, for example, if I'm just going to temporarily get rid of this here and just write else. If I say else, sponge y is going to equal to sponge y plus 5. What that means for the game is that, so I kind of missed it there. I'll grab it again. SpongeBob will, in the else, it's just, even if no matter what key is being pressed, it's going to move it down. So that's why we don't want an else there. If the person hasn't pressed a key, the right key, we don't want it to touch anything. So we are just going to leave it that way. Okay, so this is the end of this section of the video. We've got a couple of surfaces in there from these images that came from the internet, in particular DeviantArt. Again, check the comments, or sorry, the description below if you want to see where those images came from and trying to credit things properly. Then we had a little bit of code asking Pygame to check on which keys are being pressed, and we also used our clock to slow things down so it's a much more playable game. Okay, so that's it for this video. Tune in next time if you want to learn a little more.